Right. So good evening, children.
Good evening, ma'am.
Yeah, good evening, online students. Blessy, Aniruddhan, and Swati.
Good evening, ma'am.
Yeah, good evening.
Good evening.
Keshav, right? Yeah, good evening, Keshav. Yes. Yeah, online children, shared my screen. Is it visible?
Yes, ma'am.
Yes.
Yeah, very good. So, Aniruddhan, did you have time to watch the recording of the first session on trigonometry?
No, ma'am, because there is one extra animation, one subject.
Oh, okay. Fine. All right. Aniruddhan, yeah. What about you? Still watching. And you, you're ready. All right. I'll let you go. So we started from the last exercise, right? Exercise 8.3. Examples and exercise 8.3. Okay, so this is the first example. Last class, I just did a few identities randomly from the exercise. Now we'll go from the beginning. Okay, so this is example 9, the start of the examples before exercise 8.3. Okay, the first example. See this. Express the ratios cos A, tan A, and secant A in terms of sin A. You need to express cos A in terms of sin A, tan A in terms of sin A, secant A in terms of sin A. All right. Now, to express cos A in terms of sin A, you need to write some relation that connects sin and cos or their reciprocals. See, you can write a relation that connects cos and sin straight away. Or you can write a relation that connects the reciprocal of cos and sin or the reciprocal of sin and cos or their reciprocals. In the sense, you can write a relationship or you can write an identity that connects them or their reciprocals or any combination of these. We need to write cos in terms of sin. So we have these four ratios, cos, sin, the reciprocals, secant and cosecant. Now we have these four, no? You write an identity or any relation connecting, this and this, or this and this, or this and this, or this and this, anything, you will be able to get the result. All right. Now, so connecting cos and sin, we have the identity sin square A plus cos square A is equal to 1. So sin square A plus cos square A is equal to 1. So since we have to write cos in terms of sin, cos square A is equal to 1 minus sin square A. So cos A is equal to square root of, 1 minus sin square A. You can stop here, that's all. So we have written cos A in terms of sin A. Now, this doesn't mean we have sin square here, but we have to write in sin A. That's okay. It can have the power. See, like if you have to write A in terms of B, no, B can be B square, B cube, B to the power for anything. It can be anything. So we have written sin in terms of, we have written cos in terms of sin. It can be sin square A, that's okay. It can be 2 sin A. I'm just saying, for example, it can be 2 sin A. It can be 2 by 3 sin A. That's okay. We'll do this again. So we have sin square A plus cos square A is equal to 1. Why are we writing this identity? Because in this identity, we have cos and sin, and we have to write cos in terms of sin. So we choose to write this identity because we have cos and sin in this. Now we have to write cos in terms of sin. So we'll have cos on one side and take all the others to the other side. So like this it will be. But we have to write cos A, not cos square A, cos A. So cos A is equal to square root of 1 minus sin square A. Finished. We have written cos in terms of sin. Using sin. In terms of means you should write cos using sin. Using sin. So we have cos A is square root of 1 minus sine square A. Next, we have to write tan in terms of sine. Tan in terms of sine. So we can write tan A is equal to, you write any equation, write an equation, that's all. So we can write tan A is equal to sine A by cos A. Tan A sine A by cos A. This is true, no? Yeah, you can write anything. You can write anything that is true. It can be an identity or it can be some relation between the ratios. So here this is a relation between tan, sine and cos. Tan A is equal to sine A by cos A. Now we have to write tan in terms of sine. That means cos we don't want. We'll have to write tan in terms of sine. So this is equal to sine A by what is cos A? We just found root of 1 minus sine square A. So tan A is equal to tan A sine A by cos A. We have to write tan in terms of sine. That means cos should not be there. But what is that cos in terms of sine? Cos is square root of 1 minus sine square A. Now you will ask, okay, now because we already have this result, you're substituting. What if it was not there? If it was not there, you should work that. So if supposing you're working this separately, tan A is equal to sine A by cos A. You're working this independently. Then next step, you must write sine A by what is cos A? Square root of, you should, I have, in one of the videos, I have explained other interpretations of the trigonometric identities. So there I've explained all this. That's what that pre-work, you have to watch those videos. Okay, so in those videos, I've explained the interpretations of the three important trigonometric identities. So there you will see that where you have cos A, you can directly write as root of 1 minus sine square A. If you have cos A, you can straight away write it as root of 1 because cos, you can do it on your mind because cos square A is 1 minus sine square A. Cos square A is 1 minus sine square A. So cos A will be square root of 1 minus sine square A. You can do that in your mind. So you can write that straight away. Cos A is equal to root of 1 minus sine square. The last video, I think, the 8th video, if I'm not wrong. So if where you see cos A, you can write directly root of 1 minus sine square. So we have written tan in terms of sine. Next, secant in terms of sine. Secant in terms of sine. Secant in terms of sine. Now, what is the reciprocal of secant? Cos, no? So you can also write a relation between cos and sine. We have to write secant in terms of sine, no? To write this, to answer this, how do we start? We write an identity or any relation that connects these two ratios or the reciprocals. Okay, so we need to write something that connects secant and sine. But you can also write something that connects cos and sine. Because what is cos? The reciprocal of secant, right? So you can write something that connects cos and sine also. So let's write that. What is it? Cos square A plus sine square A is 1. Cos square A plus sine square A is equal to 1. We have to write secant A in terms of sine A. So you need to write a relation or an identity that connects a secant and sine. It's okay if you don't write secant, you can write its reciprocal. Cos and sine also you can write. So we have written cos square A plus sine square A is 1. This is okay. Now we'll write cos in terms of sine. So what is cos square A? 1 minus sine square A. So what is cos A? Square root of 1 minus sine square A. Now we have to write secant, right? So now how can you write cos in terms of secant? Cos is 1 by secant A. Cos A is 1 by secant A. See, now we have introduced secant. Anyways, we have cos. So now we'll introduce secant. So what is cos? 1 by secant. 1 by secant A. So see, we are not writing, we have written the equivalent. Cos A can also be written as 1 by secant A. Like if you have 10, you can write it as 7 plus 3, no? You're writing the equivalent. You're writing the equivalent. Instead of cos A, we are writing 1 by secant A. Both are equal. You can't write cos A badala, you cannot write secant A. Cos A is not equal to secant A. You cannot remove cos A and write secant A there. Cos A is not equal to secant A. cos A is equal to 1 by secant A, or secant A is equal to 1 by cos A. They are equal. So instead of cos A, we are writing 1 by secant A. They are equal. So write this as it is. Write this as it is. Now take reciprocals on both the sides. Now you take, see, like if you have B by C is equal to Y by X, you can take reciprocals on both the sides and write C by B is equal to X by Y. You can take reciprocal, whatever you do on one side, do the same thing on the other side. So we are taking reciprocals on both the sides. So what's the reciprocal of 1 by secant A? Just invert it and write it. Secant A by 1. Secant A by 1 or secant A. What's the reciprocal of this? This one is by 1. So reciprocal is 1 by root of 1 minus. That's it. All right. So this is secant A in terms of sin A. This is secant A in terms of sin A. Now you can also approach it like this. You can also approach it like this. So we have to write secant. What is secant A? Secant A is equal to 1 by cos A. So you have different ways of doing it. So secant A is equal to 1 by cos A. But we have to write secant in terms of sine, not cos. Okay, let's take away cos. So 1 by, what is cos A? Root of 1 minus sine square A. Now you will say, this is so easy. Why did you teach us that way? You can do it anyways. You can do it anyways. So you can also write, we have to write cos in terms of, sorry, cos, no? Okay, we have to continue. Oh, secant only. That's what I was wondering. Sorry. Way to write secant in terms of sine A. So you can also do this. Sorry, I saw the first one, I guess. Okay, the last one we are doing. So we have to write secant. I'm just doing the same thing in a different way. We have to write secant in terms of sine, right? So secant in terms of sine, secant A is equal to 1 by cos A. This is a relation. Secant is equal to 1 by cos is a relation. Okay, but we have to write secant in sine. So secant A is equal to 1 by, what is cos A? Root of 1 minus sine square A. So we put in secant in terms of sine. Got that? Got that, children? Yeah, write down. Yeah, today we'll be understanding and also writing out in your notebook. Please write down. Finished? Done? Yeah. Finish writing, online students?
Yes, ma'am.
Okay. Yeah, this we did the other day. Has anyone, did anyone try to complete the notes or something? No, right? From the channel? No, right? Yeah, please write on this. This we already discussed the other day. Please take it down. Example 10. Yeah. Done, children? Finished? Finished? Okay.
No, ma'am.
Oh, sorry.
Last.
Yeah, sorry. Yeah. Yeah, done?
Yes, ma'am.
Yeah. All right. Look at this one. So prove that cot A minus cos A by cot A plus cos A is equal to cosecant A minus 1 by cosecant A plus 1. Now, as we have understood, we need to change other ratios to sine or cos. All right. Okay. So in the LHS, don't write now. In the LHS, what is cot A? Cos A by sine A. Minus cos A is cos A only by cot A is cos A by sine A. Plus cos A. Now, once you start like this, you should always use algebra. Most times, it is like algebra, algebraic identities. Now, in algebra, when there is something common, we always take out the common factor, right? Whenever there's something common, see, like when you have x minus xy, immediately next step you'll say x common 1 minus y. So like this, you see here in this term and this term, cos A is common. Cos A is common. So cos A common in the bracket 1 by sine A minus 1. Cos A is common. So 1 by sine A minus 1 divided by, again cos A common in the denominator, cos A bracket 1 by sine A plus 1. Now you can cancel. Cos A gets cancelled. Okay. Now look at the RHS. What's the RHS? Cosecant A minus 1, cosecant A plus 1. We almost there to see a minus 1 plus 1, we got it. So this one should be cosecant A minus 1. This should be cosecant A plus 1. And what is 1 by sine A? Cosecant A. 1. So don't take common denominator here. Don't take the LCM. Immediately use 1 by sine A is cosecant A. 1 by sine A is cosecant A. So cosecant A minus 1 by cosecant A plus 1. Yeah. Take down. First, we write cot as cos by sine. Okay. Then, using the rules of algebra, whenever there's something common, we have to take out the common factors. So cos A is common. So in the bracket, you get 1 by sine A minus 1 in the numerator and denominator 1 by sine A plus 1. Now outside we have cos A, right? In the numerator and denominator, so cancel it. Now look at the RHS. We're almost there. We have minus 1 plus 1, but it's 1 by sine A. What is 1 by sine A? Cosecant A. So 1 by sine A is written as cosecant A plus 1 minus 1. Minus 1 plus 1. Finished? Done, children?
Yes, ma'am.
Okay. is equal to RHS ಇಲ್ಲ எழுதணும் cosecant A minus 1 by cosecant A plus 1. Okay. We did a similar one the other day. Can you help me? I think we did this one, no? We did a similar one, but I think it was this one. Right? 1 plus secant, yeah, this one we did, yes, not this. So here you can see that the left-hand side of the identity is made up of sine, cos, and 1. Look at the identity. Prove that sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1 is equal to 1 by secant theta minus tan theta. You can see that this part of the identity, it can be the LHS or RHS. So one side of the identity is made up of sine, cos, and 1. Sine, cos, and 1. Whenever one part of the identity, see, these are all identities which we are proving. This is an identity. What you see here is an identity. Okay, but you don't have to remember them, that's all. So you'll have to prove that this is an identity. It is an identity, you'll have to prove it. Now we see that one side of the identity is made up of the ratios sine theta and cos theta and 1. So then we have a specific approach. What we have to do? We have to divide the numerator and denominator either by sine theta or by cos theta. But only one of the two will work. You have to decide if you should divide by sine or cos. So you divide and see. You should divide and you should get the ratios which you have on the other side. What are the ratios you have on the other side? Secant theta and tan theta. On division, you must get secant and tan. If you get cosecant and cot, no. You should get secant and tan. So let's just divide roughly and see. So sine theta minus cos theta plus 1 divided by sine theta by, this is the denominator, sine theta plus cos theta minus 1 by sine theta. You have to do this, or this is the numerator. This is the numerator. Divide this by cos theta. This is the denominator. This is the denominator. Divide this by cos theta. So you have to do this or this. Either divide the numerator and denominator by sine theta or by cos theta. Now let's divide and check. What is sine by sine? 1. What is cos by sine? Cot. No. What is 1 by sine? Cosecant. You're sleepy. The air is making you fall asleep. Come this side and sit. Okay. 1 by sine? Cosecant. You understand what we're getting? We're getting sine by sine is 1, cos by sine is cot, and 1 by sine is cosecant. We're getting cot and cosecant. No, we need to get secant and tan. See, you do the denominator also, you'll get the same thing, no? What is sine by sine? 1. What is cos by sine? Cot. What's 1 by sine? Cosecant. No, cot, cosecant we don't want. We need secant and tan. Let's try this. Sine by cos, tan. Cos by cos, 1. 1 by cos, secant. Yeah, we are getting secant and tan here. So we need to divide the numerator and denominator by cos theta. Okay? Yes, tell me. Okay, we need to divide the numerator and denominator by cos theta. All right? Okay. We have all the steps here. Now we'll just do it roughly. So what is sine by sine? No, we'll have to divide by cos theta. So what is sine by cos? Tan theta minus cos by cos 1 plus 1 by cos secant divided by, no, I'm doing the LHS. I'm doing the LHS. All of you following? No? I'm doing the LHS. LHS is what? Sine theta minus cos theta plus 1. We're dividing this one by cos theta. We're dividing by cos theta. What do you get? 1 minus, tan theta minus 1 plus secant theta divided by Sin by cos is tan theta plus 1 minus secant theta. Now, what did we understand? Do not disturb the denominator. Do not disturb the denominator. Write the denominator as it is. I'll just write dr for denominator. Same denominator. Don't disturb. In the numerator, arrange the terms. Put 1 in the end. Now, the identity is secant square theta minus tan square theta. No? So we'll write secant theta first. Secant theta plus tan theta minus 1. Denominator and denominator, you don't have to arrange also. If you want to arrange, you put the 1. You can arrange it. See, I'm not saying don't arrange, but we are not doing any other change to the denominator. So here you can write tan theta because that's negative, no, minus secant theta. So I'm writing tan theta minus secant theta plus 1. See, denominator, you can just write it as it is. Even if you don't do this rearrangement, it's okay. No change in the denominator. In the numerator, we have secant theta plus tan theta minus 1. Put the 1 in the end. And then we have tan theta plus secant theta, but we'll write the secant theta plus tan theta because the identity is secant square theta minus tan square theta, that order, no? So we'll write secant theta plus tan theta. Next, what should you do? Remove in the next step, take away this 1. In the next step, take away 1 and write it as secant square theta minus tan square theta. Secant square theta minus tan square theta. Because what is 1? 1 can be written as sine square theta plus cos square theta. 1 can be written as secant square theta minus tan square theta. 1 can also be written as cosecant square theta minus cot square theta. But you need to use the appropriate one. So here, you will take away 1 and write as secant square theta minus tan square theta. Now, what is this? A square minus b square. Secant square theta minus tan square theta. A square minus b square. So a plus b into a minus b. That's the next step. So in the next step, we'll get secant theta plus tan theta minus a plus b, secant theta plus tan theta into a minus b, secant theta minus tan theta, divided by the denominator as it is. Now, again, like we saw in the last class, we have this one is like x. This is like x. And you have the same thing here, x, secant theta plus tan theta into y, secant theta minus tan theta. The numerator is like x minus xy. Why we're just calling this x. So you can call it a minus ab. See, a secant theta plus tan theta, here also secant theta plus tan theta. So I'm just giving it some variable. So like x and x. And this is secant theta minus tan theta. So y, that whole thing I'm calling it y. So the numerator is like x minus xy. So what's common? X is common. X is common meaning secant theta plus tan theta is common. So when you take out in x minus xy, if you take out x common, in the bracket you must write 1 minus y. So you should write 1 minus y. What is y? Secant theta minus tan theta. But take care, you'll have to use the bracket because minus y. Y itself is an expression. Correct? 1 minus y. What is y? Secant theta minus tan theta. Put it in the bracket. After the minus sign, if you're writing only one term, don't have to put the bracket. But after the minus sign, if you're writing an expression, that is something which has more than one term, please put it in a bracket. By the denominator. So this is equal to secant theta plus tan theta into 1, open the bracket, 1 minus secant theta plus tan theta. Minus into minus plus. 1 minus secant theta plus tan theta. Divided by, now let's write the denominator, tan theta minus secant theta plus 1. So see here, tan theta minus secant theta plus 1. Same terms. Tan theta minus secant theta plus 1. Tan theta minus secant theta plus 1. Same terms. So this expression gets cancelled. Same expression it is. So now we have secant theta plus tan theta. That's remaining. But what's the RHS? Secant theta minus tan theta. But we have what? Secant theta plus tan theta. I'll just clear the screen. We have secant theta plus tan theta. But the RHS is actually 1 by secant theta minus tan theta. So you should multiply by, you need to get secant theta minus tan theta in the denominator, right? So put that in the denominator. Whatever you have to get, put it. So write the same thing in the numerator. Because as I told you in the last class, it's like multiplying by 1. Like multiplying by 1. We are multiplying by secant theta minus tan theta by secant theta minus tan theta. So it's like cancel 1 into 1. But then why are we doing this? Because the RHS, in the RHS in the denominator, we have secant theta minus tan theta. We want that. So just take it, that's all. All right. Okay. So now what should you do? You have to multiply the numerators. Not LCM, it's multiplication. So no LCM here. Common denominator is only when it is plus minus in the middle. This is multiplication. So multiply the numerators. A plus B into A minus B. Secant theta plus tan theta into secant theta minus tan theta. A plus B into A minus B. A squared minus B squared. So secant square theta minus tan square theta. What is secant square theta minus tan square theta? 1. Secant square theta. Secant square theta minus tan square theta. What is it? It's 1 by secant theta minus tan theta. So 1 by secant theta minus tan theta. All right. Yeah. Write down quickly. Any questions? Completed writing, online students?
Yes,
No,
ma'am.
ma'am.
Okay. Yeah, those who have finished, any questions?
No, ma'am.
Okay. Finished? All right. Done, Aniruddhan?
Ma'am, last 2 steps, ma'am.
Yeah.
Yes, ma'am. Complete.
Yeah, thank you. Yeah, see this. Express the trigonometric ratios of sine A, secant A, and tan A in terms of cot A. Okay, so can I get it from you? So first we need to write sine A in terms of cot A. We need to write sine A in terms of cot A. Cot A, okay, cot and sine directly there is no relationship. Like you can write cot A is cos A by sine A. That's one way of writing. You can write cot A is equal to cos A by sine A. Cos A by sine A. Or think about this identity, cosecant square A minus cot square A is equal to 1, right? See, it should take some time to understand what to write. You cannot, as soon as you see this, you cannot write something immediately. In the rough column, you just write, you see what all, is available for you. Just give yourself some time to think about how to get started. So in the rough column, we're just writing what all we can, write about them. So cot A is cos A by sine A. Cosecant square A minus cot square A is 1, right? And what cosecant is what? 1 by sine. It's a reciprocal of sine, no? Cosecant is a reciprocal of sine. So I think we can use this, right? Because we need to write sine in terms of cot. We'll write cosecant in terms of cot and then write cosecant in terms of sine. We'll have to write sine in terms of cot. We have chosen this identity. Now in this identity, we have cosecant and cot. So what we'll do, we'll write cosecant A in terms of cot A. Then we know that cosecant is 1 by sine, no? So then we'll replace cosecant is 1 by sine and then eventually you'll get sine in terms of cot. So to answer the first one, sine A in terms of cot A, we write this identity cosecant square A minus cot square A is equal to 1. Now we are going to write cosecant in terms of cot. So cosecant square A is equal to 1 plus cot square A. So cosecant A is equal to square root of 1 plus cot square A. Now we'll write cosecant as sine, meaning cosecant in terms of sine. So cosecant is nothing but 1 by sine A is equal to square root of 1 plus cot square A. Now we'll take reciprocals on both the sides. So reciprocal of this is this, and the reciprocal of this one is. All right? Yeah, write down. Okay, so next we have to write secant A in terms of cot A. We have to write secant in terms of cot, secant and cot. No, but we can write an identity that connects secant and tan. And tan and cot are reciprocal ratios. So you can write this one. So secant square A minus tan square A is equal to 1. This one has secant and it has tan, which is a reciprocal of cot. So secant square A is equal to 1 plus tan square A. So secant A is equal to square root of 1 plus tan square A. Now we need to, secant A will be secant A. Now this tan should become cot. Tan should be written as cot. So it will be 1 plus, what is tan square A? Tan square A, what is tan A? 1 by cot A. So tan square A, okay. What is tan A? Tan A is equal to 1 by cot A. Now square on both the sides. Square on both. It's like A is equal to B. So A square is equal to B square. Tan A is equal to 1 by cot A. So tan square A is equal to 1 by cot square A. You can also cube it on both the sides, and if needed, tan cubed A is equal to 1 by cot cubed A. It's true. Tan A is equal to 1 by cot A. So you square in your mind, you square on both the sides. So tan square A is equal to 1 by cot square A. Because 1 square is 1 only. So 1 by cot square A. 1 by cot square A. Correct? All right. Now you have to take the common denominator. Cot square A is a common denominator. So in the numerator, you will get cot square A plus 1. Secant A is equal to square root of cot square A plus 1 by cot square A. So we've written secant in terms of cot, but we can simplify a little further. Is equal to square root of cot square A plus 1 by square root of cot square A is cot A. Numerator is square root of cot square A plus 1. That you cannot take the individual square roots. You cannot, it's not cot A plus 1. Square root of A square plus B square is not equal to A plus B. Square root of A square plus B square. There's plus in the middle, no? So you cannot write square root of A square is A, square root of B square is B. So it is A plus B. No, it's not true. Square root of A square plus B square is not equal to A plus B. So square root of cot square A plus 1. You cannot take the individual square roots. Cot square is cot A, 1 is 1, so cot A plus 1. No, it's not true. But if it's a product, square root of A square into B square, if it's a product, yeah, then you can take individual square roots. Is equal to AB. Square root of A square into B square. For multiplication and division, A square by B square also, you can take the individual square roots. When it's plus minus in the middle, you cannot. So numerator will be as it is, divided by square root of cot square A is cot A. Right on? So when is school reopening for 10th standard? 15th March. For all others, it started, no? Okay. Third one also written here. Tan A, the third one. Tan A in terms of cot A. See, tan A is equal to 1 by cot A. Tan A in terms of cot A, tan A is equal to 1 by cot A. Correct? Yeah, finish this one. Third one is here. All right? Okay. Online children, finished?
Yes, ma'am.
No, ma'am.
Okay. Okay. Yeah. Next one. Write the other trigonometric ratios. Write the other trigonometric ratios of A in terms of secant A. A is the angle, the acute angle. Write the other trigonometric ratios of A. A is the angle in terms of secant A. That means you must write sin A in terms of secant A, cos A in terms of secant A, tan A in terms of secant A, cosecant A in terms of secant A, and cot A in terms of secant A. So sin A in terms of secant A. Now that you've understood, I'll just write it. You also understand and take it down along with me. Yeah, start writing with me. This is 4. I didn't write cos in terms. Third one, what is 3? Cos A in terms of IV. Okay. Actually, that should be a third one. I was just trying to write in an order. So sine, we understood. Sine in terms of secant. Then after writing sine, I wrote cosecant because reciprocal, right? So once you write sine in terms of secant, write the reciprocal. What is the reciprocal of sine A? Cosecant A. So cosecant A will be secant A by root of secant square A minus 1. So render ratio முடிச்சிட்டோம். Sine A எழுதினோடனே right for cosecant A because it's just going to be the reciprocal. If you write later, maybe we'll forget. We'll again try to derive it. So once you write sine A, immediately write cosecant A because we just have to invert it and write it. Okay. So after sine, what should you write? So sine I wrote and then I wrote cosecant. That is the reciprocal. Next, what should I write? Cos, no? I missed to write that. So I'm writing that is 3. Okay. That is 3. Third, just change the number. That's all. So third one is cos A in terms of, take another slide, but that's the third one. Cos A in terms of secant A. So what is it? Cos A is equal to 1 by secant A. Then this is the fourth one. What we've already written, no? This is the fourth one. Just change the number. That's it. நீங்க முன்னாடி 3 ன்னு போட்டதே இப்ப 4 ன்னு போட்டு இப்ப 3 எழுதுங்க அவ்வளவுதான். Already what you've written, change the number to 4 and now this is 3. Okay. So we wrote sine, then we wrote cosecant, then cos in terms of secant. And what's the reciprocal of cos? Secant. So that we don't have to write. Reciprocal of secant, you don't have to write. Okay, then tan. Tan in terms of secant. Secant square A minus tan square A is 1. So tan square A is secant square A minus 1. Because if we take this minus tan square A to the other side, it will become plus tan square A. So tan square A is secant square A minus 1. Why have we taken this one to the RHS? Because it's minus tan square A. So if you take it to the RHS, it will become plus tan square A. So we have tan square A is equal to secant square A minus 1. So tan square A. So tan A is equal to square root of secant square A minus 1. So we've written tan in terms of secant. Tan in terms of secant. Tan mattumna tan square, tan cube la tan. Tan A in terms of your writing, no, there it can be anything. See, it's secant square. That's okay. This you don't have to change. We have written tan A in terms of secant A. Okay, then finally cot. Cot A in terms of secant A. So what is tan? So as tan A is equal to square root of secant square A minus 1. Cot A will be equal to 1 by square root of secant square A minus 1. Because we got tan A here, root of secant square A minus 1. So cot A reciprocal will be 1 by secant square root of secant square A minus 1. Yeah, right on. All right. Finished, all of you? Okay. This is the next question. So we finished, this was 2. Question number 2. Hope I'm giving you the numbers correctly. After example 12 is exercise 8.3. This is exercise 8.3, first one. After example 12, this is the exercise first one. Second one in the exercise. This is the third one in the exercise. All right? Yeah. So question number 3, the first one. Choose the option. 9 secant square A minus 9 tan square A is equal to. So you can take out 9 common, right? You can take out 9 common. So you'll get secant square A minus tan square A. So what's the answer? What's the answer? 9. 9 into 1, 9. Why? Because 9 into secant square A minus tan square A is 1. So 9 into 1, 9. This is the option. Yeah, right on. Third one, question number 3. Choose the correct option. Four options are given. The correct option is B. Justification is the working, that's all. The working is the justification. So this reason is the identity. Because secant square theta minus tan square theta is 1. The reason why we are writing secant square A minus tan square A is 1, because this is the identity. Secant square theta minus tan square theta is 1 for that reason. Finished? Yeah. This is the next one. So you need to work this. So this one, the value of this expression is equal to an integer. You can see the options. You can see the options 0, 1, 2, minus 1. So that means the value of this expression is an integer. This one represents an integer. Okay. So see here. So we have 1 minus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. This is given. What's the rule? 1 minus, what's the rule? Change other ratios to sine or cos. Okay. So tan theta is sine theta by cos theta plus secant theta is 1 by cos theta. Change other ratios to sine and cos or sine or cos. 1 plus cos theta by sine theta minus 1 by sine theta. This is the first step. Changing the ratios, other ratios to sine cos. Then you have to take the common denominator. Cos theta is a common denominator. So you will get cos theta minus sine theta plus 1 sine theta plus cos theta minus 1 by sine theta. Now we'll have to multiply. There's no sign, meaning it's multiplication here. We'll have to multiply. So we'll have to multiply the numerators, multiply the denominators. In the numerator, we have 3 terms. So if you have to do the, see in the numerators, we have 3 terms, right? So again, algebra, how to multiply? You should multiply, one second, like if you have to multiply A plus B plus C with A minus B minus C, you'll have to multiply A with the second bracket A minus B minus C, then multiply B with the second bracket A minus B minus C, then multiply C with the second bracket A minus B minus C. Multiply every term of the first bracket with the second bracket. That's how we multiply, right? We'll have to multiply every term in the first bracket, A with the second bracket, then plus B into the second bracket, plus C into the second bracket. That is algebraic multiplication. That's what we'll have to do here. So that is one option. You can multiply like this, but this is going to take a, okay. So you'll have to see if you can simplify, save time by using an identity. That's what I'm trying to say. This is how you'll have to multiply. You'll have to multiply cos theta with sine theta plus cos theta minus 1. Then minus sine theta with sine theta plus cos theta minus 1. And plus 1 with sine theta plus cos theta minus 1. The usual multiplication. You get it, you will get the same answer. Even if you don't use an identity, whatever answer you should get, you will get the same thing. But the purpose of using an identity is to save time. It's to save time. And also, it's easy to check the steps. If you have multiplication, terms varo. Identity, when you use identity, you have lesser terms also. Okay, so for that, what we do is, when you look at the numerators, we have cos sine 1, cos sine 1. Same thing we have. So let's just rearrange. So you can write this as cos theta minus sine theta plus 1. Cos theta plus sine theta minus 1. Divided by cos theta into sine theta. See, we have to multiply the numerators, multiply the denominators. We have multiplied the denominators. Cos theta and sin theta is cos theta, sin theta. We have multiplied. Numerators to multiply, we'll use an identity. For that, we'll have to rearrange the terms. So on observing the numerators, you can write them as cos theta minus sin theta in a bracket plus 1, like A plus B. And again, oh, 1 minute. Sign here is 1 minute. The sign is different. 1 second. Have we messed with the sign anywhere? Cos theta minus sin theta. Signs must match. 1 second. See if I have the question correct first. Oh, the sign here, see, it's a, I put a plus here. I've messed the question. I'll just check. 1 second. Can you see in the working, I put a plus here? Can you see here in the working, I put a plus? So this one is a plus. While typing, I've made a mistake. It's a plus here, children. I don't have the textbook. See here, while working, can you see I put a plus here while working? So that means this is 1 plus tan theta. While typing, I've made a mistake in the sign. Yeah, if you have the textbook, you can see it. Okay. One plus, no? That's right. 1 plus. Okay, children, see. So this plus, children. Okay, it's 1 plus. So now we can plus, plus, plus. Yeah. Yeah. So sin theta plus cos theta plus 1 by into sin theta plus cos theta minus 1 by, you can write sin theta into cos theta or cos theta into sin theta, whatever. So when you look at the numerators, the terms are the same. So we have written it in the form a plus b into a minus b, where a is sin theta plus cos theta. See, the terms are the same. Sin theta plus cos theta written in a bracket plus 1. Then sin theta plus cos theta in a bracket minus 1. So this is like, this is a plus this is b. And this is a minus b. Can you see what is a? Sin theta plus cos theta is a. Sin theta plus cos theta is a. Plus b plus 1. Then again sin theta minus, sin theta plus cos theta is a minus b minus 1. Can we see that? So what is a? Sin theta plus cos theta. What is b? 1. B is 1. A sin theta plus cos theta. All right. So next step will be a plus b into a minus b is a square. This is a, right? A. This is a. A square minus b square divided by sin theta cos theta. Now expand this. Sin theta plus cos theta the whole square expanded. So it will be a square. A plus b the whole square is a square plus b square plus 2ab, 2 sin theta cos theta minus 1 divided by sin theta cos theta. Then in the numerator, sin square theta plus cos square theta. This one is 1, no? Sin square theta plus cos square theta is 1. And 1 and minus 1 will get cancelled. 1 and minus 1 cancels. So you're left with 2 sin theta cos theta. 2 sin theta cos theta by sin theta cos theta. So cancels and the integer value is 2. All right? Yeah. Work. Please work. So we use this identity. We rearrange the terms and we make it look like an identity to save time in working ahead. Otherwise, we'll have to do the regular multiplication as we discussed the first term with the second bracket, second term with the second bracket, third term with the second bracket, you'll get the same answer. But you have to use identity because you need to get used to new things, right? Identity you have learned in 8th standard, but to use that identity here, okay, so it's new, so you'll have to get used to this. Don't stick to that old method of multiplying the regular multiplication. Please use the identity. Finish writing? Yeah. Okay. Next one. Question number 3, third subdivision. Again, 4 options we have. So we are given secant A plus tan A into 1 minus sin A. Tell me. Next step, what? Quickly. 1 by fast cos A plus sin A by cos A into this one as it is, no? Yeah. Next step. 1 plus sin A by cos A. Yeah. Into sin A. Next. Next. How cos A by cos A? Next, what should we do next? Like, how much? Common denominator. No, it's multiplication. It's multiplication. Yes.
We can use the A plus B and A minus B.
Yeah, we'll have to multiply the numerators. We'll have to multiply the numerators, no? This is like by 1 here. See, if you have 2 by 5 into 3, what will you do next? 2 into 3, 6. 6 by 5, no? Won't you do this? Same thing. It's multiplication. So we'll have to multiply the numerators using the identity. Correct, Swati. So 1 plus sin A into 1 minus sin A. A plus B into A minus B. A square minus sin square A by multiply the denominators. Cos A. Cos A is equal to, what is 1 minus sin square A? Cos square A. 1 minus sin square A. Because sin square A plus cos square A is equal to 1. So when you take this here, cos square A is equal to 1 minus sin square A. Cos square A is equal to 1 minus sin square A. So 1 minus sin square A is cos square A. Cos square A by cos A. So what is A square by A? A square by A. So cos square A means what? Cos A into cos A. What is cos square A? Cos A into cos A. By cos A. So cos A gets, so cos A is the result. I don't. there's a reason. What you see here is a reason. Because sine square A plus cos square A is 1. Cos square A is equal to 1 minus sine square A is a reason. No, I'm saying don't mistake it as something is multiplied. I've written the reason in the bracket here. Finished? Yeah. Okay, next one. Now, whenever we have tan and cot together in an expression, you know, we have an option. See, like when the expression has only tan and cot, we have an option like you can change it to sine cos, or you can change tan to cot, cot to tan. Normally, what we have to do when we have other ratios, we'll have to change them to sine cos. That's the rule. And we use that rule everywhere. Now, when we have tan and cot alone, we have an expression, we have only tan and cot. Here, we have two options. Either you can change tan and cot to sine cos. You can do that. Or what you can do is, the other option you have is, you can retain tan and change cot to tan. Or you can retain cot and change tan to cot. That other option is available. Okay. So let's start. So you can suppose we have tan as it is and we change cot. So it'll be 1 plus tan square A by 1 plus 1 by tan square A. Correct? Tan and cot. So we're retaining tan, we're changing cot to tan. Okay. So once you do this, the next step is common denominator. Tan square A is the common denominator, right? So you'll get 1 plus tan square A. So see here, this is the numerator, children. This is the numerator. This full thing is the denominator actually. Because this one is 1 plus cot square A. This one is the denominator. So this is the numerator. This is the denominator. You understand what I mean? See, this one is that 1 plus cot square A, denominator. So this is the denominator. So it is 1 plus tan square A. This is the numerator divided by 1 plus tan square A by tan square A. So 1 plus tan square A into tan square A by 1 plus tan square A. So tan square A. Tan square A. Yeah. Please write. Finished? Yeah. Okay. Yeah. So in question number 4, we have 10 identities to prove. With that, exercise 8.3 comes to an end. All right. So let's see the first one. LHS. Now you want to tell me? Yeah, quickly. First step. Write other ratios in terms of sine cos. Write other ratios in terms of sine cos. Hmm. The first step. Next. Okay. RHS whole square லாம் இல்ல. So என்ன பண்ணலாம்? We'll write this separately. Cos theta whole square by sine theta whole square to sine square theta. Now you should look at the RHS and you know, like analyze like what to do, which one to change ahead. இது வரைக்கும் we got it. Now after this, what to do? Look at the RHS. In the RHS, 1 minus cos theta we have, but now at present we have 1 minus cos theta the whole square. So அப்படின்னா ஒரு 1 minus cos theta cancel ஆகும். அப்ப ஒரு 1 minus cos theta cancel ஆகணும்னா கீழே அந்த 1 minus cos theta you should have it in the denominator, right? அப்ப sin square theta மாத்தணும். At present we have this one, which is close to the RHS. In the RHS, the numerator we have 1 minus cos theta. Presently, we have 1 minus cos theta, the whole square. So we have it, we have extra. You should remove 1 minus cos theta. For that, you should have 1 minus cos theta in the denominator. Only then they'll get cancelled, right? So denominator should be 1 minus cos theta, but you have sin square theta. So that means you should change that. And also in the RHS, we don't have sin. We have only cos. So next step, you should write 1 minus cos theta into 1 minus cos theta. Write it 2 times. Write it 2 times. 1 minus cos theta into 1 minus cos theta divided by sin square theta is 1 minus cos square theta. Because RHS we have only cos, we don't have sin. Then next step, 1 minus cos theta into 1 minus cos theta by this a square minus b square. So a plus b into a minus b. So 1 minus cos theta into 1 plus cos theta. So like this, they get cancelled and we have the RHS. All right? Yeah, write down. So first is the general rule, changing it to sine cos. Finished? Online children, finished writing?
Yes, ma'am.
Okay. This is the second one. This we finished in the last class. Please write down. So here we already have sine cos only. So we have to take the common denominator. We already have sine cos in the LHS. So just take the common denominator and proceed.
Completed, ma'am.
Yeah. This also we finished in the last class. I think from here, because I want to explain the rest of the identities in this exercise. So I'll explain the rest, and then if I don't think we'll have time. So the rest of this you have to complete by tomorrow's class. You have to finish writing by tomorrow's class. So this one you can use the recording. I'll share the recording with you, the earlier sessions recording. This one is explained, okay? So you can. All right, children. So now I'll explain So we understood this by changing the left-hand side in terms of sine cos. But I just told you one rule, no? That if the expression is made up of only tan and cot, you have an option. Yeah, you can change cot to tan or tan to cot. You have that option when the expression is entirely made up of tan and cot. So we understood this in terms of sine cos in the last class. Now we'll see this in terms of tan. Okay. So it's tan theta. Okay, let's start from here. Tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Okay. So I'll just do the same thing I've done here because I can share the same working. Okay. I've changed cot. You can also change tan, children. Okay. Okay, so in the working here, I've written tan, I've changed cot to tan. I'll do the same thing now so that I can share the same image with you. You can also try the other way. You will get this correct result. So I've written tan as it is. Now 1 minus cot is 1 by tan plus cot is 1 by tan and denominator 1 minus tan theta as it is. So here you should be very, careful with the numerator and denominator. Which part is the numerator? This one is the numerator. This one is the denominator. Here, this is the numerator. This full thing is the denominator. Is equal to tan theta by, on taking the LCM, you'll get tan theta minus 1 by tan theta. Plus here 1 by tan theta divided by 1 minus tan theta. Nothing can be done here. Okay. Next step. Next step, which is the numerator? This one is the numerator, no? This is the numerator divided by this one. So it'll become into, see, it will be divided by, this is the denominator, tan theta minus 1 by tan theta. This is the denominator, right? So in the next step, it will become into tan theta by tan theta minus 1. The next step, it will become into tan theta by tan theta minus 1. Because this is numerator, this one is denominator. So it will be divided by this one. So it will become into reciprocal tan theta by tan theta minus 1 plus here, which is the numerator, this one is the numerator. 1 by tan theta, this is the numerator, divided by 1 minus tan theta, divided by 1 minus tan theta. So it will become into 1 by 1 minus tan theta. This is the numerator tan theta divided by, this is the denominator tan theta minus 1 by tan theta plus this is the numerator divided by, this one is the denominator. So next step, tan theta into tan theta by tan theta minus 1 plus 1 by tan theta into 1 by 1 minus tan theta. So next step, tan theta into, see, this is one thing, this is the other thing, and connected by a plus sign. All right, so tan theta into tan theta is tan square theta by 1. It's like 1 here, so 1 into tan theta minus 1 is tan theta minus 1. Plus, here also multiply the numerators. 1 by multiply the denominators. So it will be tan theta into 1 minus tan theta. Then remember, last class we understood something. If we have a minus b and you want to write it as b minus a, take a minus outside. Take a minus outside. We have tan theta minus 1, but here we have 1 minus tan theta. So you want to write this one also as tan theta minus 1, so that it's easy to take the common denominator. So the next step, what will happen is next step, okay? I am doing the change here, but you should do it in the next step. What you should do is write this 1 minus tan theta as tan theta minus 1. Write this one as tan theta minus 1. That is a minus b, write it as b minus a, tan theta minus 1. And take a minus outside. So when you take this minus outside, this minus into plus will become minus. Minus into plus will become minus. Minus. All right. So now the common denominator is tan theta. The common denominator is tan theta into tan theta minus 1. Tan theta into tan theta minus 1. This is the common denominator. Tan theta into tan theta minus 1, correct? So now inga tan theta minus 1 irukku. So you should multiply with tan theta. The denominator of this one is there. What's not there? Tan theta. So you should multiply the numerator with tan theta. So tan square theta, there's already a square into a cubed. So tan cubed theta. Tan square theta into tan theta is tan cubed theta. Minus, inga ellame irukku. So minus 1 as it is. Because the same denominator it is. So minus 1. Now the numerator is in the form a cubed minus b cubed. It's in the form a cubed minus b cubed. A cubed minus b cubed is a cubed minus b cubed is a minus b into a square minus ab, sorry, plus ab plus b square. A cubed minus b cubed is a minus b into a square plus ab plus b square. So using that, tan cubed theta minus 1 cubed is, what is a there? Tan theta, b 1, a minus b, tan theta minus 1 into a square plus ab plus a into b plus b square. Oh, plus 1. Sorry. Plus 1. Divided by whatever you have here. Tan theta into tan theta minus 1. Tan theta into tan theta minus 1. A cubed minus b cubed is a minus b, a squared plus ab plus b squared. Okay. So இது வந்து நம்ம tan theta into 1 வெறும் tan theta ன்னு எழுதிடலாம். Tan theta into 1 is nothing but tan theta. So this one and this one will get cancelled. Now look at the RHS. What is the RHS? How many terms are there in the RHS? 1 plus secant, 2 terms are there. 1 plus secant theta cosecant theta, only 2 terms are there. Okay, so now what is 1 plus tan square theta? Secant square theta. 1 plus tan square theta is secant square theta. No, now here in the numerator there are 3 terms, but here in the RHS there are only 2 terms. So we can write 1 plus tan square theta as secant square theta. Secant square theta plus tan theta by tan theta. So now divide individually. So secant square theta by tan theta plus tan theta by tan theta. So now the secant square theta by tan theta, no, so it's difficult to proceed. So we'll write like this. So easy to proceed. Secant square theta divided by tan theta like this, plus 1. I always use this form so that it's easy for me to explain and for you also to understand. Secant square theta divided by tan theta, just written like this, plus 1. Okay. Now what is secant square theta? 1 by cos square theta. What is secant square theta? 1 by cos square theta. Secant theta is 1 by cos theta. Secant square theta is 1 by cos square theta. Divided by sin theta by cos theta. So it will be into cos theta by sin theta. It's easy to write like this. You have to write as 1 by cos square theta divided by sin theta by cos theta. Now you might go wrong, like which one to take to the numerator and denominator. You might go wrong. So if you write it like this, no, you cannot go wrong. In the division use பண்ணாம எப்படி பண்ணோம்னா இப்படி substitute பண்ணோம். Secant square theta is 1 by cos square theta like this by tan theta sin theta by cos theta. Like this you should proceed. If you're comfortable working like this, you can do it like this itself. I always convert this division to this division. So it's easy to write. Secant square theta is 1 by cos square theta. Division becomes multiplication. Tan is sin by cos, so it will become cos by sin here. Plus 1. Now this and this, correct, is equal to, now what do you have? 1 by cos theta, secant theta. Then this is 1 by sin theta, cosecant theta. 1 by cos theta, secant theta. 1 by sin theta, cosecant theta, plus 1, which is the RHS. 1 plus secant theta, cosecant theta. 1 plus cosecant theta, secant theta. It's cold there, we'll turn it off. Okay, that's the RHS. Tired or? Okay, so that's about the alternate working. Okay, so this image, these images, I think it is on the channel. I'll share it in the group on WhatsApp. Yeah. This also I explained in the last class. Okay. This also I explained in the last class. This one only, now we did one. Okay, this was explained in the last class. Okay. Cos, sin, and 1. Remember, cos, sin, 1. So you should divide the numerator and denominator by sin or cos. That sum this is. Okay, yeah, this one. So square root of 1 plus sin A by 1 minus sin A. So to get rid of the square root, like 9th standard, you know, to rationalize the denominator, we used to multiply and divide by the conjugate, no? 9th standard. To rationalize the denominator, we used to multiply and divide by the conjugate. So here also do that same thing. What's the denominator? 1 minus sin A. So multiply and divide by 1 plus sin A. Under the square root only you should do that. Extend that square root symbol and do it under the square root. Here it's minus, so you multiply and divide by plus 1 plus sin A. So under the square root it will be, under the square root it will be 1 plus sin A into 1 plus sin A. So 1 plus sin A the whole square divided by 1 minus sin A into 1 plus sin A. A square minus B square. So 1 minus sin square A. And what is 1 minus sin square A? Cos square A. Next step you should write that. You should not write the step straight away. Next step. So 1 minus sin square A we'll get, and 1 minus sin square A is cos square A. Now recall. So under the square root, when we have perfect squares, you can get rid of the square root. Under the square root, when we have perfect squares, you can get rid of the square root symbol. So what do you have? Square root of 1 plus sin A the whole square. So you can you can bring it out of the square root, right? So it'll become 1 plus sin A. Square root podavanda. And cos square A under the square root. So it will come out of the square root as cos A. Both are perfect squares. 1 plus sin A the whole square. Cos A the whole square. So they'll come out of the square root like this. Now there's nothing but 1 by cos A plus sin A by cos A. What happened? Okay. So there's nothing but 1 by cos A plus sin A by cos A. So 1 by cos A is secant A plus sin A by cos A is tan A. All right. That's it. So remember, if you have to get rid of the square root symbol, the expressions must be perfect squares. Only then you can get rid of the square root symbol. So we made them perfect squares. And now we've got rid of the square root symbol. Then divide like this, 1 by cos A plus sin A by cos A. See, like if you have A plus B by C, you can write it as A by C plus B by C. 1 by cos A plus sin A by cos A. So secant A plus tan. The 6th one. Yeah. So this I have done it in 3 different ways. So in order to finish it faster, I'll just use the slide and explain, because we just. have to finish it, so I'll not leave you. Yeah, all right, children. So 7th subdivision. So you can see here in both the numerator and the denominator, there is something common. What's common? In the numerator, sine theta is common. In the denominator, cos theta is common. In the numerator, you can see sine theta common. In the denominator, cos theta common. And also the ratios in the left-hand side are already sine and cos. So that rule to change to sine and cos, we don't have to apply because it's already in sine and cos. So then what to do? Whenever there's something common, take out the common factor. So sine theta is common in the numerator, cos theta is common in the denominator, bring it out. So that will give you this step after taking out sine theta and cos theta common. Now what is sine theta by cos theta, children? Tan theta. And this one I've written as it is, 1 minus 2 sine. This one I've written as it is. And what is the RHS, by the way? Tan theta. Oh, we already got it. This is the RHS. That means these two are equal. They should get cancelled. See, on taking sine theta common in the numerator and cos theta common in the denominator, we already got the RHS. Sine theta by cos theta is tan theta. We already got it. We already got the RHS, yes or no? So then this one you should remove this. How can you remove this? Only when you can cancel these two. Only when you can cancel these two. That means these two are equal. They don't look equal, but you must make them equal. Okay, so how do we do that? So you can do it in 3 different ways. Method 1, what you see here is, we have sine and cos, no? I've written this denominator as it is. In the numerator, I've written sine square theta as 1 minus cos square theta. That's one method. What you need to understand is sine theta by cos theta is tan theta, which is the RHS. So we need to eliminate these two like this. They're equal. The numerator and denominator, they're equal. They'll get cancelled like this, right? Okay, so how you should make that? So how do you show that they're equal? So in this method, the first column, I have not disturbed the denominator. In the numerator, the sine square theta I've written it as 1 minus cos square theta. So then what will happen? Minus 2 minus into minus plus 2 cos square theta. Then this 1 minus 2 is minus 1. So 2 cos square theta minus 1. So now you can see, you get the same thing. They get cancelled and tan theta is the result. Nothing. What we've done is denominator we did not disturb. In the numerator, because denominator has cos, numerator also, instead of sine square theta, we write it as 1 minus cos square theta. Then when you work the denominator and numerator, they are the same. They get cancelled and tan theta is the result. In the next one, in the second column, what you see is, again, sine theta, take out common. So sine theta by cos theta, tan theta, we have the result. So here what I've done is, numerator I've written as it is, 1 minus 2 sine square theta as it is. In the denominator, instead of cos square theta, I've written 1 minus sine square theta. We have 2 cos square theta, no? So instead of cos square theta, write 2 cos square theta, no? What is cos square theta? 1 minus sine square theta in bracket. Cos square theta is 1 minus sine square theta in bracket. And then this minus 1, this minus 1. Now, open the bracket. 2 into 1, 2. 2 into minus sine square theta, minus 2 sine square theta, minus 1. Now this 2 minus 1. What is 2 minus 1? 1. Minus 1 minus 2 sine square theta. 1 simplifying. 2 minus 1 is 1. Minus 2 sine square theta. So you have the same thing. They get cancelled. So tan theta, which is RHS. In the third column, what you see is, take out sine theta, cos theta common. So you got tan theta. In the third column, there is this 1, no? In both the numerator and denominator, instead of 1, you write sine square theta plus cos square theta. That's the third method. In both, here you should change in both the numerator and the denominator. In both the numerator and denominator, where there is 1, you know, you write it as sine square theta plus cos square theta. Write this as it is, this one as it is. In the denominator also, write this 2 cos square theta as it is. See here, 2 cos square theta as it is. This minus 1, no? Minus 1, what is 1? Sine square theta plus cos square theta. After minus, if you're writing more than one term, you should put it in the bracket. after a minus sign, if you're writing more than one term, put it in a bracket. So -1 here, after minus there is only 1. There is no bracket there. But when you're replacing 1 with sine square theta plus cos square theta, minus, this is 1. But this one has more than one term, so you should put in a bracket. So in the next step, it will become minus sine square theta minus cos square theta. Then when you simplify the like terms and all that, you will get the same thing. So they get cancelled and tan theta. So these are the 3 different methods. It's easy. Nothing like, no, for me, first method is easy. I'll remember this. Nothing like that. Everything is equally easy. Okay. It's just that you realize that you already got the RHS tan theta. So you should realize that these two are equal. You should cancel them. In order to cancel them, you should make them look the same. They are the same, but they don't look like that, no? So you should make them look they're equal. For that, yeah, all this you should do. So here we did not disturb the denominator. We changed the numerator. Here we kept the numerator as it is, change the denominator. That is, here in the first method, we changed sine square theta to 1 minus cos square theta. In the next method, we changed cos square theta to 1 minus sine square theta. In the third method, we didn't disturb sine square theta and cos square theta. We took a totally different idea. That one, no, we write 1 as sine square theta plus cos square theta. That's the third method. So till here, you have to complete, all the answers in your notebook by tomorrow's class. Till here. Okay, I'll put this on WhatsApp. All right. All right, children. So that's it for today's session. Thank you. Good night. And for those who do not know, yeah, online children, thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you.
Ma'am?
Yeah, just a second. I just need to make an announcement here. Just a second.